Welcome to INTELLO videos. A work system is a set of devices used together to run an electrochemical measurement by connecting it to an electrochemical cell. The electrochemical cell is not considered part of the work system. A work system reflects the physical setup used, how the devices are connected to each other, and the configuration of each device. Depending on the experimental and application requirements, additional devices such as rotating electrodes, like a rotating disc or rotating cylinder electrode, thermocouples, or oscilloscope could be used together with VIONIC. In its most basic form, a work system typically consists only of one VIONIC instrument in the role of main instrument. In this example, no additional devices are connected to VIONIC. To create an advanced work system, in the Work System Editor window in INTELLO, the external devices from the Known Devices list can be dragged and dropped into the field adjacent to the main instrument. In the Work System Editor window, the Autolab RDE rotating disc electrode is added as an Autolab accessory. Once added, it should appear in the Known Devices list under Autolab Accessory Group. For applications and experiments which require hydrodynamic measurements with rotating electrodes, a work system can be created by adding an Autolab rotating disc electrode or an Autolab rotating cylinder electrode to the VIONIC main instrument, as shown in this slide. A BNC cable is connected from the analog output of VIONIC to the analog input of the motor controller. For applications and experiments which require temperature monitoring during the electrochemical measurements, a work system can be created by adding a K-type thermocouple to the back panel of VIONIC main instrument. For applications and experiments which require external monitoring of measured electrochemical signals, for example the potential and the current, a work system can be created by enabling the E-out and the I-out of the VIONIC main instrument. A common example when such a work system would be used is the case when the measured potential and or current needs to be monitored by an oscilloscope. Welcome to INTELLO. There's a work system panel in the home screen of INTELLO. You will see here. Here you see the panel of known devices. These devices are known by the database of the present user, meaning that MVD has once worked with the Bravo instrument. So this is the user and once worked with Bravo instrument. The work system tiles have a status indicator in the top right corner. The status is indicated by a color and a symbol. Right now, Alpha Work System is claimed, indicated by a lock symbol. Someone other than the user MVD has claimed it, which is indicated by the gray color. The colors and symbols are explained by the user manual. In this video, I will focus on the states relevant with one user is working with one work system. In order to change the setting, like putting a thermocouple to the Bravo instrument, we must claim the instrument first. Select the tile of Bravo, and you will see the claim button appear. When you press Alpha, you don't see a claim button, because that's already claimed by test. So get back to Bravo, and here you can say claim and connect to the work system. We are brought to a manual control and monitor screen of Bravo. On the right side panel, we see a work system of Bravo and an indicator icon. The right side panel, so this one here, is always visible, no matter what you're doing in the software. So you will always have the status of the work system in your view. This indicator gives a lot of information, including procedure running, yes or no, with a heartbeat pulse, in the inner rectangular, or if the cell is on and off in this circle. Overloads will appear as yellow and errors will appear in red in here as well. The colors and symbols are explained in the user manual. Now let's get back to the idea of changing the work system settings. This can be done from the manual control and monitoring screen or from the home screen. In each context, there's a little pencil button that lets you edit the work system. Here you'll find the pencil button. When you press this pencil button, you can configure the work system. In the Setup Work System dialog, we can add additional devices, for example, a thermocouple. Select the plus button, this one here, and then you can decide what kind of device you want to add to the main instrument. So for example, you can select Autolab accessories like the rotating disc electrode or rotating cylinder electrode, or you can select other devices like a thermocouple or a third-party rotator. So you can also connect another type of rotator to the VIONIC. But here we're going to show the thermocouple and give it a name T1, for example. T1 becomes available under known devices, and then we can drag and drop the thermocouple inside the main instrument. And in here you will find a specific place for the thermocouple, K-type thermocouple. When you close it, you'll see the temperature becomes immediately available in the home screen. Now I want to show you how to measure this temperature in a procedure. We take, for example, the critical pitting temperature based on ASTM method G150. This is described in the application note Core 006. If you go to the Autolab library and double click on the procedure, so we go to Home, Procedures, Chronoamperometry, and it will be automatically selected to the main instrument, to Bravo. In this study, a 1 liter Autolab corrosion cell is used. This jacketed corrosion cell has an inlet and outlet for the water bath to control the temperature. The temperature of the cell was controlled by a Julabo thermal bath. First, the solution was cooled to 6 degrees centigrade, and then an open circle potential was measured for 30 minutes. An overpotential of 100 mV above OCP was applied, and the temperature was raised until 80 degrees centigrade with a rate of 1 degree centigrade per minute in order to explore the potential independent critical pitting temperature. First, we select in the sequence the procedure. And there we define what kind of system we have. We have an instrument with a thermocouple. Press OK. If a procedure is prepared offline, so without having a work system connected and claimed, for an experiment which requires an Autolab rotating disc electrode or any other type of additional devices, the required work system must be defined in advance in this procedure setting tile of the respective procedure. So this is very important when you design a procedure without a VIONIC claimed. So we've added the thermocouple, then add an OCP command. We can add an OCP command by drag and drop it in the list. For time restrictions, we only measure the OCP for, let's say, 10 seconds. Normally, you measure for 30 minutes, but for this video, I'm just typing in time seconds. Select the chronometer icon, and in here, we're going to unlink the potential we're going to apply, 0.1 volts or 100 millivolts with respect to OCP. The duration, we also unlink up till 1 hour. And the sampling type, we can have a data point every 500 milliseconds. Yeah, so these are the settings. And then you can define the signals. So the temperature is already enabled, and we're going to measure the potential and the current. And with the rules, we can add a cutoff value when the current becomes bigger than 10 milliamp, for example. 10 milliamp. Stop the procedure. So when the current becomes larger than 10 milliamp, it will stop the procedure and it runs into the end state. So my procedure is finished. I'm going to create a custom plot. So I'm going to drag and drop my measurement into a custom plot. On the x-axis, put time. On the y-axis, we put temperature. And on the other y-axis, we put current, like this. Yeah, can create. So this is created. And now we can start the procedure. The run button is available and the data will be stored in my personal folder, which is called CPT. We start. Well, first the OCP is measured for 10 seconds. Normally for this method you take 30 minutes. But this isn't just an example to show how it's running. Stabilizing for 5 seconds and then 100 millivolt will be applied versus OCP. And at the same time, the temperature is recorded. You see the blue line is my temperature, which is at the moment stable. And when you switch on the water bath, we can increase the temperature. And at the red line, you see the current appearing. Yeah, so this is measured. So when we finish this experiment, you'll see something like this. Ramping up the temperature is the blue line, and at a certain time, so roughly around 750 seconds at 54 degrees, you'll see that the stainless steel parts is starting to pit because of the increase of the current. Yeah. So this is running. We can stop the measurement because the results are there, like this. Now I'll show you how to release a work system. You see this button here, release work system and disconnect. This should be done when you want to stop working with the work system and make it available for other users in your network to claim. The release button is located on the right side panel and also the manual control and monitoring screen. So release it, and now if you go to my home screen, you see both are released. You can reclaim, of course, with pressing this button. So in this video, we have covered creating a work system, claiming and releasing the work system, changing the work system settings, the work system indicators in the home screen and on the right side panel, and running a procedure in the work system. Thank you for watching INTELLO videos. If you found this INTELLO video helpful, please like and share with your colleagues. You can subscribe to the Metrohm Autolab YouTube channel so you are notified when new videos are available.